There's a number that keeps showing up everywhere you look. When a population grows, when a bank quietly pays you interest, when a virus spreads through a city, when your own cells divide, when an AI model learns from data. And the strangest part, nobody sat down and invented this number. Nature revealed it, whether anyone was looking or not. One single number secretly runs all of them. Everyone knows the number pi, but there's another number, quieter and arguably just as important. Mathematicians simply call it E, roughly 271,828, an infinite decimal that never repeats, exactly like pi. But E doesn't come from circles or triangles or any shape at all. It comes from something far more ordinary, money and how it grows. Which raises an odd question. How does a banking calculation end up as a fundamental constant of the universe? Amsterdam, 1683. A mathematician named Jacob Bernoulli is puzzling over compound interest. Picture a bank that pays 100% interest once a year. Simple enough, your money doubles. $1 becomes $2. But Bernoulli asks a stranger question. What if that same interest is split and paid twice a year, 50% each time? $1 grows to $1.50 and then $1.50 grows to $2.25. That's already more than simple doubling. So what happens if the bank compounds 4 times a year, or monthly, or daily? Every time you compound more often, you squeeze out a little more growth. Bernoulli pushes the question to its breaking point. What if interest compounds infinitely often, continuously, every single instant? Does the money grow forever, without any limit at all? It's a strange thing to wonder about in the 1680, long before calculus was fully formed. But Bernoulli doesn't just wonder. He sits down and actually calculates it. He publishes his findings mostly as a curiosity, without fully realizing what he had just found. It's a question that seems almost too simple for the mathematics available in the 1600. Compounding n times a year multiplies your dollar by one simple expression, repeated n times. Once a year, your dollar becomes 200. Twice a year, 225. Compounded monthly, 613. Compounded daily, 714. Compounded every second of the year, 71,828. And then, no matter how much finer you slice time, the number simply stops climbing. Slice a year into 1,000,000 pieces, 1,000,000,000 pieces, it makes no difference. The value locks onto a single fixed point, 718,281,828. That fixed number is what we now call E. But this was never really about banking. It's the mathematical signature of continuous growth itself. Any quantity that grows in proportion to how much of it already exists behaves this exact way. Take a colony of bacteria. The more bacteria you already have, the faster new ones appear. A population grows in proportion to its current size. A radioactive sample decays in proportion to what's left of it. Even a cup of coffee cools down in proportion to how much hotter it still is than the room. In every one of these, E is the number quietly running the math underneath. That's why calculus falls in love with E. Draw the curve E to the power of x, and something remarkable happens. At every single point on that curve, its slope exactly equals its own height. It is, quite literally, its own rate of change. No other curve in mathematics behaves like that. Even today, mathematicians still debate exactly why Euler picked the letter E. Decades later, Leonhard Euler picks this number up and runs with it. He gives it the single letter we still use today, E. Euler shows it isn't just a constant for growth and decay. He connects it to trigonometry, to rotation, to imaginary numbers. He even builds an entirely new logarithm system around it, the natural logarithm. One single equation ties E, pi 0, 1, and the imaginary unit together. E to the power of I times pi plus 1 equals 0. 5 of the most important numbers in all of mathematics, in one line. A number that was born from a question about compound interest turns out to sit at the center of mathematics itself. Not a quirky coincidence of banking. A fundamental constant of the universe, as essential as pi. Later, mathematicians prove E is irrational, like pi. It's even transcendental. No simple algebraic equation can ever produce it exactly. Today, E shows up anywhere continuous growth happens. Population and ecology models are built on it. Compound interest and investment growth still run on exactly the formula Bernoulli stumbled onto. Radioactive decay and the carbon dating used to date fossils depend on it directly. So does the half-life of a drug, breaking down inside your own bloodstream. The early stage of an epidemic spreading through a population follows an E-based curve. Neural networks use E inside the functions that let an AI make decisions and predictions. The bell curve at the heart of statistics has E built directly into its formula. Even the natural logarithm, used from pH levels to sound measured in decibels, is just the mirror image of E. Every one of these is the same idea wearing a different disguise. Continuous, proportional growth. Sound fading in a room, an echo dying out, a signal weakening over distance, all fade along an E-based curve. Insurance companies use it to model risk continuously, instead of only checking once a year. Even the quick doubling time shortcut bankers and scientists still use today comes directly from E. Pi describes curves. E describes life. It shows up again and again because growth itself is built out of it. As if nature had already chosen this number, quietly, long before a mathematician in Amsterdam ever noticed it. He wasn't inventing something new. He was just the first person to write it down. Two quiet numbers, pi and E, running almost everything we ever measure. Once you know to look for it, you can't stop noticing it. Every video on this channel is built around one idea, one pivotal moment that quietly changed everything, explained clearly in under 15 minutes. If that's useful to you, subscribing means you don't miss the next one, and there's always a next one. And if this video changed how you think about something, even a little, hitting like is what tells YouTube to show it to someone else who needs it too. If this one was worth your time, there's another turning point video waiting for you right there.